Hello everyone, it's me Arvin catching you on another Math Tutor Edu's math content video. Okay, in this video I'm going to discuss a new topic within the derivatives advanced mathematics, which is implicit differentiation. Okay, so what is implicit differentiation basically? Okay, before this we have actually conduct the explicit differentiation, which I can say it's actually a normal differentiation. For example, let's say if I give a y equation is equals to 3x squared plus 4x plus 5. Okay, if I differentiate this with respect to x, so in this case dy over dx will be equals to, okay, 2 times 3 will be 6, okay, the power 2 will be minus 1, okay, so from here 6x plus with 4. Okay, this differentiation is also known as explicit differentiation. Okay, so what we are doing up until now is explicit differentiation. Okay, imagine that you don't have one-sided equation which is y, where everything is combined together, where x and y in a side and then another variables at a side. Okay, I mean x and y, they are mixed together in both sides. Okay, in that case we unable to solve them using explicit differentiation. We only can do it using implicit differentiation. Okay, you might wondering what am I talking about. Okay, let me show you the example itself. Okay, let's say you have x squared plus with 2xy is equals to 3x. okay, in this case, so it is highly recommended that we can solve this question using the implicit differentiation method. Okay, so how this implicit differentiation method works is basically you need to differentiate both sides of the equation with respect to x, and then we need to treat this y as a differentiable function of x. So let's say, for example, if I'm using the implicit differentiation method for this equation, so from here when I differentiate this, okay, x squared, I'll get 2x, okay, and then plus with, okay, since this 2xy, we can treat it as a product rule, so we're going to differentiate the x first. So from here it will be 2y, okay, because differentiate 2x, you only left with 2 and you times with y, okay, and then plus with, okay, and then this y we're going to treat it as a function itself. Okay, so how are you going to do that? Okay, when you differentiate y, in this case you're going to left with 1, okay, 1 times with 2x, so in this case will be 2x. okay, but in a condition over here you need to write the dy over dx function over here, dy over dx. okay, in this case is dy over dx, so in future if you're doing using the y prime, you need to mention the y prime over here. Okay, but for now we're using the dy over dx. okay, so 2x, provided that you need to times with dy over dx. okay, so from here now will be equals to 3. okay, on your right side when you differentiate with respect to x, you get equals to 3. okay, so from now let us group dy dx variable in a side and then the other variables another side. So from here 2x times with dy over dx, okay, so from here will be equals to 3 minus 2x minus 2y. okay, so from here to get the dy over dx, what you're going to do, so we're going to divide this 3 minus 2x minus 2y, divide the whole equation by 2x. so from here dy over dx, so in this case will be equals to 3 minus 2x minus 2y divided with 2x. okay, you can just leave your answer in this way. okay, so let me underline the solution. okay, so of course you can able to factor out this x term. okay, so how are you going to do that? okay, it's very simple, where 2xy will be equals to 3x and then minus x square, and then from here to get the y, what you do, 3x minus x square, and then you divide with 2x. Yes, that is possible. Okay, but then it will be longer steps, and this will be lead us to the explicit differentiation. Okay, so using this method, okay, we can conclude that this can be possibly solved using the implicit differentiation method. Okay, so from here, enough with the explanation, so let us proceed to our example now. Okay, so from here, let us start with the first example. Okay, example A. So we're going to start with the considered to be an easy example, guys. Okay, so from here, let's say I have an equation of x square plus with y square equals to 1. So we're going to use the implicit differentiation to solve this. Okay, as usual, so we're going to differentiate both sides with respect to x. Okay, so from here, let us begin. So x square, when you differentiate, you get is 2x. Okay, y square, so you need to treat it as an equation itself. Assume it like it is relatable to x, but the only thing is you need to follow the y variable. So from here, 2y. Okay, and then you need to add the dy, times with dy over dx equals to 0. Okay, so this 2x, we can move it to the right hand side. So from here, 2y dy over dx, okay, is equals to negative 2x. Okay, so from here, dy over dx, so will be equals to negative 2x divided with 2y. Okay, so from here you can factor out the 2. So from here you get your final answer will be negative x over y. So this will be your answer for the question part A. So far so good. Okay, this is considered an easy example. Okay, let us try a bit complex one. Okay, so from here, x square. Okay, let's say you have an equation of x square plus with sine y is equals to 1. Okay, so we're going to solve this using the implicit differentiation method. Okay, similar case. So differentiate both sides with respect to x, and the y equation you need to treat it as it is an x like, okay, double quoted x like, guys. Okay, but then you need to times with dy over dx or y prime. Okay, so from here, x square, when you differentiate, you get is 2x. Okay, sine y, you differentiate, you get is cos y. Okay, and remember to times with dy over dx. Okay, this is for the left hand side. For your right hand side, okay, 1, when you differentiate 1, okay, since it's a constant, it will be 0. Okay, so from here, I'm sure the step will be quite simple from now. Okay, this 2x from the left hand side, you move it over to the right hand side. So from here, cos y dy over dx, so it will be equals to negative 2x. So since we are finding the dy over dx, so what you're going to do is this negative 2x, we're going to divide with cos y. So from here, dy over dx will be equals to negative 2x over cos y. Okay, so let me underline the fraction. Okay, and underline the solution as well. Okay, so you have done 2 examples till now. Okay, let us move on to the example C. Okay, so time to increase the difficulty a bit. So from here, let's say you have an equation of x squared y plus with xy squared is equals to 6. Okay, so the question asks you to solve this equation using the implicit differentiation. That means they ask you to find the dy over dx using the implicit differentiation method. So how are we going to solve? Okay, so from here, same step, okay, both sides you need to differentiate with respect to x. Okay, so let us start with this set of variable x square y. Okay, so from here we start to treat this as a product rule. Let us differentiate the x first. Okay, so from here x square y, so it will be 2xy plus, okay, since we are treating this as a product rule, okay, we differentiate the x first and then followed by differentiate the y. Okay, so differentiate the y, so from here it will be x square times with dy over dx. Okay, so technically you differentiate y, you get is 1. Okay, we are treating this as an implicit differentiation. We are treating this as a variable of x alike, guys. Okay, but then when you differentiate this, you need to write the dy over dx beside, okay, to indicate that it is a multiplication. Okay, and then of course it is an implicit differentiation as well. Okay, so we're done with the first one. Let us proceed to the second one. Okay, plus with, okay, xy square. Let us start with the x. Okay, so from here get is y square. Okay, and then followed by, okay, so we differentiate y square now. Okay, just now we differentiate the x, now we differentiate the y square, so it will be 2xy times with dy over dx equals to 0. Okay, so now what you're going to do is we're going to group the dy over dx variable in the left hand side and then the other variables in the right hand side. So we're going to move them. Okay, so from here, okay, so x square dy over dx plus with 2xy times with dy over dx, okay, will be equals to negative 2xy plus with, minus with y square. Okay, why minus? Because we are moving this to the right hand side, so from positive it will become negative. Okay, so up until now I hope you guys are clear. So for the next step, what you're going to do is for the left hand side of the equation, we're going to factor out the dy over dx. Okay, let's factor them out. So dy over dx, okay, when you factorize you get x square plus with 2xy close bracket equals to negative 2xy minus y square. Okay, since we're going to find the dy over dx, so it will be negative 2xy minus y squared divided with x squared plus with 2xy. Okay, so from here negative 2xy minus y squared, okay, and then you divide with x squared plus with 2xy. Okay, so let me underline the fraction and the solution. Okay, so don't worry, we still have a few more practice to do. Okay, so by end of this video you should be able to master the implicit differentiation concept. Okay, the steps are pretty similar, guys. Okay, first step, you differentiate both sides with respect to x, and then you group the dy over dx in a side and then group the other variable another side, and then you find the dy over dx. Okay, the only thing you need to be slightly careful when you're differentiating the complex variables, okay, which involving the products rule and the trigonometry. Okay, so that's the thing you need to be slightly careful, otherwise we can able to solve this. Okay, let us proceed to the example D. Let's say you have a equation of 2 square root y, okay, equals to x minus y. Okay, now it's getting a little bit difficult. Now we have a set over here for square root. Okay, so for the first step, what you're going to do is we're going to make this in a form of a power or index form. Okay, so this square root y, we're going to make it as 2 y to the power of 1 over 2 is equals to x minus y. Okay, why we are doing this? So that it will be easier for us to perform the differentiation, okay, later on. Okay, so from here we're going to differentiate this with respect to x. So from here we're going to differentiate this, so half times with 2 you get is 1, okay, and the power you minus with 1, so from here you get is y to the power of negative 1 over 2. Okay, make sure you times with dy over dx, okay, equals to, okay, x you differentiate you get is 1, okay, and then negative y, so negative y you differentiate you get is negative 1 times with dy over dx, so technically you only write negative dy over dx. Okay, it is understood, guys. Okay, okay, so far, so your guys are clear. Okay, for the next step, what I'm going to do is I'm going to change this from index form. We're going to write it back to the fraction form. Okay, because our power is in negative form. So from here, y to the power of negative 1 over 2, I'm going to write it as 1 over square root y, okay, times with dy over dx equals to 1 minus dy over dx. Okay, now things are okay, so we can group the dy over dx term in a side and then the variable another side. Okay, so from here, 1 over square root y dy over dx plus with dy over dx is equals to 1. Okay, so from here, what we're going to do is we're going to factor out the dy over dx. So let's factor them out. So dy over dx, okay, you factorize them, so you're only left with 1 over square root y plus with 1. Okay, dy over dx, so we factor out, it will be 1 and then equals to 1. Okay, we are very close to our final step, so I hope you understand the step-by-step working that I'm showing to you till now. Okay, by the way, this is d. Okay, so from here, your dy over dx, okay, will be equals to, okay, 1. Okay, let me draw the fraction line. Okay, and then divide with, okay, this term. Okay, let me copy paste this. Okay, 1 over square root y plus 1. Okay, since we have 1 over square root y plus 1, so this is an indication of 1, so we can just straightly convert this as dy over dx in index form, where it will be 1 over surd y or square root y plus with 1, okay, to the power of negative 1. Okay, because in your numerator you only have 1, guys. Okay, so you can change this into negative 1. Okay, you can leave your answer in this way, or if you want to make it slightly better, you can leave it in this way as well. Okay, it is up to you. Okay, so from here, let us underline the solution. Okay, so we still have one more example left to discuss. Okay, so let us move on to the example E. Okay, for the example E, so it's given that for example, like tangent x over y is equals to 1. Okay, now it's getting way more trickier as we are involving trigonometry, and then a bit of chain rule we are going to apply over here. Okay, so from here, still the same, the step is still the same. Okay, first step is we're going to differentiate both sides with respect to x, and then we're going to group them, the dy over dx another side, and then from there we're going to find the implicit differentiation. Okay, so I recommend you to pay attention for this particular question because it's slightly tricky. Okay, let me perform this one by one. Okay, so tangent x over y, so we're going to start to differentiate with x first. Okay, since tangent, and then inside the tangent function you have x over y. Okay, so we're going to differentiate the tangent function itself first. Okay, so from here, when you differentiate tangent, you get secant square. So from here, secant square, okay, and then in the bracket x over y, okay, times with, okay, now we're going to differentiate the x first. Okay, so when you differentiate the x, so that means you're going to differentiate the inside bracket, guys, x over y. Okay, x over y, when you differentiate it, you only left with 1 over y. Okay, let me do this step by step. Okay, so we're done with the x, okay, part. Now we focus on the y part. Okay, plus, okay, this is considered a chain rule or products rule. Okay, consider a chain rule, guys. Okay, this is part of a chain rule and a products rule, a combination. Okay, now Still the same, tangent x over y. So we're going to differentiate the tangent function first. So we differentiate the tangent function, you get the same thing, secant square x over y. Okay, let me just copy paste this as it's the same. Okay, secant square x over y. Okay, now we're going to differentiate the y. Okay, in this case, we're going to differentiate only the y part, guys. Okay, the x is going to leave it as a constant. Okay, so from here, when you differentiate x over y, so from here you're going to get negative x over y squared. Okay, and then make sure you add a dy over dx times with dy over dx. Okay, and then equals to 0. Okay, so how we get this? Okay, very simple, guys. Okay, let me just show you a quick explanation over this side. Okay, so from here, x over y. Okay, and then so since you're only differentiating the y part, so from here x y to the power of negative 1. Okay, so from here negative x y to the power of negative 2. So from here you get negative x over y squared. So that's how you get over here, guys. So I just saved some steps for you. Okay, so from here we're going to move this set of equation to the right hand side, and then keep this dy over dx equation in our left hand side. So from here secant square x over y, okay, and then times with negative x over y square, okay, times with dy over dx will be equals to negative secant square x over y times with 1 over y. Okay, so from here the secant square x over y and secant square x over y, we can cancel them out. Okay, so you're only left with negative x over y square dy over dx is equals to negative 1 over y. Okay, so for the next step, what you're going to do is we're going to try to factor out the y. Okay, negative 1 over y. We're going to try to eliminate the y function. So how are you going to do that? So we're going to times negative y in the both side of the equation. So from here it will be negative, it will be positive x over y dy over dx equals to 1. Okay, so x over y dy over dx is equals to 1. So from here dy over dx will be equals to 1 divided with x over y. Since this is a fraction, so we flip the position of the numerator and denominator. So from here you get dy over dx will be equals to y over x. So this is your answer. So let me underline the solution. Okay, so give me a minute. Okay, so let me scroll it up. Okay, so we have come to the end of the video of implicit differentiation. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming advanced mathematics video in the future. And make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.